Hello friends, welcome to Data Pandit. So today we are going to talk about shared variable collection. So this is an advanced type of uh, is in-memory in-memory data set basically. Okay, so we have a keyed data store, right? So if we talk about key-based storage, right, like lookup, we will have a key and one or more values, right? And then the extended part is like icff. There also we have a key and value, and then there is a map. So this is also a composite data type. Okay. Now, so that is also have a key value pair thing. And now we have a SVC. This is a in memory. This is a different from map actually. Map is a map is a storage, but it is not an in memory basically. Okay, but SVC is the in memory data set. So this is also one type of key data set. Okay, there will be a key and corresponding value. So if we talk about the definition of it, like shared variable collection is a global variable. So so when we talk global variable, right? So in a particular process like reformat process or rollup process, in the sense of reformat component transform, right? We take global variable. So this is also a type of global variable that is part of shared variable, global variable used synchronously in a component fold. So within a process, we can you can update it and reference it. Okay. So we are going to see how we are within an example, but in the definition, like it can be used in any transform where we have to declare the variables, and then in memory we can store the reference the variable or also update the value of it. Okay. Okay, based on the key. Okay, and the usage is, if we talk about the different usages, like it can be used as a web service graph. So what will happen is we create the web service, right? And then how we create the web services? So we HTTP subscribe. We can take the request, and then maybe we have some subgraph or graph which used as shared variable collection, and then we use the HTTP publish. Okay, so this kind of mechanism we can have, like, okay, and it can be used in batch graph also. So we need to take care, like, whatever is in the batch graph, right? Whatever is the referencing and updating part happens, right, within a batch graph. It should be in a single process, meaning all those components must be foldable components so that they can communicate between the processes. Like we have, let's say we have a input file, and then we have reformat one, uh, and then again we have a reformat two, right, in the graph, right, and then there is an output file, let's say output file. Then what we need to do is, like, all these components, right, these between these components, and if we are referring the, let's say we are updating some shared variable collection for a particular row here, and we are referring again back here, right, then all these reformat 1 and 2 should be foldable. I mean, these must be executed as a single process, right? So we have talked about the map in our earlier video. You can check it. ICFF also, lookup, and now it is SVC. And in SVC, I also talked about web services graph, right, as part of micrograph. And I have talked about the component folding concept. So the new concepts are coming, and we are referring all those concepts again back. Okay, so SVC is the new one, and in the continuous graph also, what we can do is we have continuously data is coming in. Let's say if we talk about share market, share values, right? So for a particular moment, the value of the share price is changing, right, for a particular CDOL or particular ticker, right? So in that kind of scenarios, we can subscribe the amount ticker values, and what we can use the graph which manipulates and store in memory, SVC. The so new for a particular key, the new value is getting into the next, let's say, next checkpoint. So that value is going to be updated again, and in the next moment another value is coming, so that will be updated again back, right? So in those kind of situations, we can use the um, right shared variable collection. This is in memory storage, right? So the previous value can be referenced back, right, and then can be updated back in storage. So and if you want to make it persistent, we can store that value in some directory. Let's say for a for a particular queue or a particular checkpoint, we want to store the values for a particular keyed storage. We can create a journal, right, in a disk. So we can provide the path. We are going to see that thing, right, in the next, when we are going to talk about the exact example where how it is going to be used. So service graph can be directly called from the web browser. So in advanced things, like what we can do is this: we can create a web service graph, and that service can be called from a web browser also. We will be talking about in detail in some other videos, okay, but that can be done. So the service graph can utilize the SVC to service the particular web service from the browser, right? The service, the client server mechanism kind of thing. So we have talked about, we have understood the shared variable collections. Now let's look at the implementation of it, okay? How we are going to implement it. So in that implementation, we will have to have, so I have a, let's say, graph, right? So we have an input data set, and are going to have some. I have taken the batch graph. It can be uh, it can be transformed or created in a continuous graph also, wherein we will not use input file and output file. Rather, we are going to use the subscribe component or publish component, okay? Or it can be used other other components which publish the checkpoint, right? Other subscribe component, right? Maybe queues or JMS queues, or other queues also, right? So let's talk about the SVC creation part, right? So I have an input data similar like in batch graph, this kind of data, and we will have then a reformat. First reformat is going to be created, is create. We will create the shared variable collection over here. Then in the second reformat component, I will refer that shared variable collection. But these two components, reformat 1 and 2, are going to be executed as a single process. We will make sure that this graph is allowed component folding. Okay, we will go to the graph settings and right, and then enable the folded components, right, and then there will be an output. So you know that whenever we create the graph, we can we can allow the component folding in the graph, right, to modify the settings when create the graph. So let's talk about how to create the shared variable, okay? So we will need to create this. For creating the shared variable, we need to define one collection, actually, in the sense of we will have some XFR, in the sense of transform file we need to create. So we will have a package. We will create the package like this: package SVC underscore PKG. So this is going to be a normal package, right? When we create any other package, right? So this package will contain some methods and the variables, right? So this key type is a variable of string 3 I have taken this time, and then long state is another variable, and then there is a method, and then there is a handle. Actually, this is a pointer to the particular key, okay, particular collection basically. So SCV handle, SV create collection. This is the inbuilt function, and it will accept key type, and it will accept, let's say, max heap memory, or if you want to persistent the storage in this particular server location, we can have persistent. Okay, so what it is going to happen is, like, it will store the intermediate data into this directory, actually, for a particular shared variable collection. Okay, normally we don't use the persistent storage, okay, But if you want to do like to establish the recovery mechanism in the case of continuous graph, right? So we can use the persistent storage, basically persistent storage directory. So right, and then there is a method. So this initialize is like it is going to construct the shared variable collection. So basically the shared variable collection can be equated with the class of any other language. Let's say Java, we have a classes, right? Classes, and then there will be object and methods. So we will have a constructor there, right? So to initialize the variables, right? So here also we will have a constructor kind of initialize, and it will accept one parameter called key. So because it's a key driven thing, right? So everything happens based on key. So it will accept key as a argument, and then it will assign, let's say state is variable, right? Long state is a variable. So it initializes the variable with the 0 amount. So this is another write to log file is another optional function. So I have used this here. Okay. So this is going to one function. Another function is update state internal. So it will be called, okay, and it will accept one argument value, and for that particular key this value is going to be updated. Let's say state is going to be state plus incoming value. So whatever is the state it existed, we can increment it. Like there are two methods here. First, to update the state in the sense of updating the key key value pair, and then get state is the referencing that key value pair, right? So there are two things: get state internal and update state internal and get state. So these get state and update states are going to be called from any other reformat whenever we are going to use the state value collection, and these function direct then in turn will call the, you know, update state internal, these functions. Okay. And sv apply is another inbuilt function actually. So this will call the this update set state or get state internal. So this is altogether the entire package definition. So we will store this entire package definition under the some xfr file. Okay, let's call it as a svc collection.xfr. And whenever we are using, like we are going to use in this reformat and this reformat, right? So, okay, so we are going to use like this. We can include this collection xfr, and then we can refer. So update state and the, so svc package dot update state is a function, right? You can see update state is a function. So it will accept two arguments. So see here, n dot key, n dot value. So right, and let's say I want to update a value for a particular key. So from here input file, and this reformat will be called, and create update state is going to be called for a particular key, and then value is going to be passed, and then it will go here update state and key long value, then sv apply. So here and we are in the package. So sv apply is an inbuilt function. It will accept handle and then key, which is coming from the original reformat function wherein we have calling, and then update state intelligent another function. This is here. This is the how we define the, you know, package actually, svc package, thread variable collection package, and then the value. So it will go here and then update the value. State is state plus value. Value is the value and state is the existed state, right? So it will be called for a particular key again and again, and is going to update for a particular key value pair, right? And then, for example, so first this thing, right? We are used in the create SVC. Okay, this reformat is for this one. So so it will be used as to update the values, and then we will refer these values again in the next reformat. So call, now we use the call svc. So we will use the same package, same we'll include it, and in the next reformat we will use the get state. So whenever we'll call the get state for a particular key, right? So it is going to be called in this package is like it will call get state, key is key, and then it will call the get state internal. When we call get state internal, it will return the state. What is the current state of the particular key, right? Current value of the particular key, let's say in this example, right? So this is update state internally is going to update the value for a particular key. Okay, and get state is going to return the value of that. So in this graph, right, simple graph, first we are going to update the values, and then we are going to refer that value for a particular key, right? So key value pair is going to be passed, and then it will update and it will refer. So, and both these function, reformat 1 and 2 will be foldable, and the foldable component will behave as it is a single process, right? So it will not have two reformat process, rather it is going to be have a single reformat process, and this reformat process will be sharing the same particular collection of the shared variable collection. So let's say, let's understand this picture. So we have input this one, output this one. So E1, E2, E3 and all these keys I have passed as an input, and the corresponding values are this. So I have E1 39. So for a particular E1, 39 is going to be value, right? Because we have updated this value using this reformat, like get state, update state, right? So for that particular instance, even correspond to the 39, right? So whenever I call, right, this value in this that instant even again, so it will refer the 39, because corresponding value for even at that moment in time is 39. Then E2 2, E3 98, E2 again, because it's a repeated value, because key is again, right? So whenever record 4 is coming into this reformat, what is going to happen? It is going to happen is E2 is the, already there is a key E2, right? Because we have a two value. So what is going to have is state is 2, existing state is 2, right? And new value is, what is the fourth record new value? New value is 34. So 2 plus 34 is going to be 36. So at that moment in time, whenever call SVC function is called, so E2 will return the 38, 36, right? So the result is, if you look at here, when I'm referring, so I'm creating a long, the result. So the result, if you're looking at here, the result is the, I'm referring the value of the key for that particular moment in time while passing the key. So it will give me the current state of the value, the key, current state of the key. Similarly, E5 at that moment in time 8, E3, E3 is also repeated, so it becomes 100, 98 plus 200, right? E4, 4, E5, E5 is again, I think it's repeated, right? 8 plus 9, 17. E5 it was earlier 8, but next time 17. So this time, so this shared value collection can be used in stock market, because stock market values are getting updated and earlier value is getting wiped out, right? In those case of scenarios, right? So wherein we have a kind of you know um, new values are coming frequently. New values are coming in the flow frequently, and we are interested in the new value. Actually, we are not interested in the old values. Okay, for a particular ticker or a particular CDOL, new prices are coming, so those prices are going to be the reference, the, we need the updated price, right, that particular moment in time. So we need that. So irrespective of how many records we have read so far, in the sense of this is in memory, so it's a very efficient. So and also uh, if we have uh, a variable like in in traveling, so let's say one vehicle is traveling from point number A to point number B, right? This is the source and destination, and we have a checkpoints, right? A1, we'll see A2, right? And we will want to check that, how much we have traveled so far. Let's say at point in time A2 we want to check. So what is going to happen is, all right, so how much distance we have traveled is, like if A1 we will update the value, right? And is point in A3, at A3 we want to see that how much is traveled is, like how far this car has been, I mean, how far how much distance it is traveled, right? at a particular time. So at location B, we want to see at that particular point in time. What we can do is we can see the updated variable. Let's say we have variable for that, right? And as soon as it updates also and it refers also, right? So that kind of use case we can another type of use case could be for n memory, because it's an n memory, so efficiency purpose we can use it. So because we don't have to go to the disk and see the values, it's in memory storage basically. So the key value pair storage will happen in the in memory. Okay. And other cases, like we will have a multiple sets of data values, right? Like I talked about, right? There are a lot of share market things. So for a particular share market, values is getting updated. So that kind of scenario we can use it. Okay. And if you want to storage it, that also can be storage, right? Persistent storage we can have. So in between values, if you want to store it, then we can also use the this like I talked about, right? This persistent storage. So this is basically in memory efficient and key value storage. So this is all about shared variable collection. Thank you so much.